we're going to present the assignment 2 of constraint optimization with using the Lagrangian multiplier method. We're going to explain the basic concepts about the Lagrangian method. So first of all, when we have two equations, we have here f of x and y and g of xy, we're going to, the Lagrangian multiplier method is to obtain a function that combines these two, and here this would be our basic equation in which we want to obtain the maximum, and here is our constrained function. So the Lagrangian method formula would be f of xy equals f of xy minus lambda g of xy minus c, because this is when the equation is equal to 0. So equals c, and this would help us to, after this, we would have to differentiate this function with respect to x and with respect to y, and then equal and solve to 0. And that's what we'll see in this example. To make these exercises, we're gonna sum it up into 6 steps. The first of all is to write the data of the exercise. The second one will be to use the Lagrangian function. So to put these two functions into the Lagrangian function, then we will differentiate the Lagrangian with respect to x and with respect to y, and also include the main constraint function, and then we will equal each of the differentiated functions to 0, and we will solve, which will give us step 5. We will solve for x and y, and we will plug it into the main function. And then some final calculations to make the solution. So we already wrote down the data of the exercise, and now we will have to put these two equations into the Lagrangian function. So now we're going to differentiate this with respect to x and with respect to y. And that is the differentiated function, and now we will make it equal to 0 and solve.
So we write the constraint function, as we will need to plug in the answers that we get after equaling the answers of equaling to 0 the derivatives of x and y. So we first do it with x. So we would plug it into the constraint function. So if we plug the values that we obtain into the constraint function, we will obtain the value of lambda. And if we plug the value of lambda into these values, we will obtain the maximum value that we can then plug into the main function. Okay, so we start x is this plus 2 times minus lambda equals 8. So we pass it to here, we leave minus lambda by itself, and it would be 16 divided by 5, which give us the value of minus lambda. So if we plug it here, we would have that x is this into the main function, we will obtain the maximum of the main function.
So this is our main function, and if we plug in the value that we have just obtained, we would have 32 divided by 5 squared minus 16 divided by 5 squared. And if we calculate this, we would obtain
that the maximum for the main function with the constraint that we have obtained, it would be minus 36.2. So in this case, we're asked to find the minimum value, but we're going to follow the 6 same steps that we followed to find the maximum. The only difference is that the answer that we're going to get is the minimum value. So we already got the data, and we're going to do the Lagrangian, which is. And now we're going to find the first derivative with respect to x and with respect to y.
So now we need to set our two partial derivatives equal to 0. So we'll have for f of x.
For 2x minus 5 lambda equals to 0, and for y, 2y minus 2 lambda equals to 0.
So for y, we're gonna for x. And for y, we're gonna have
2y equals 2 lambda, and y is equal to 2 over 2 lambda, which is x equal to lambda.
So now that we have x and y according to lambda, we're gonna substitute this result in our constraint equation. So it will give us 5. Okay, so now that we found that lambda is equal to 10.57, we're going to substitute this result in the place of lambda, so it will give us
5 over 14 divided by 10.57, which is equal to 3.75, so we're going to
3.78. And for y, it's easy, it's as lambda is it, so it's equal to 10.57. So now that we have our 2 points, this means that the minimum occurs and so now we're gonna plug these two points into the original function. So and so when we add these two numbers, we arrive to 211.7437. So this means that the minimum value of the function according to the constraint is equal to 211.7437.